Hi everyone, really good to see you today. Matthew Kennedy here. I'm doing my discussion board for Module 6, which really deals with answering two prompts. And because I am in 4110, I'll be responding to two prompts tonight, number 1 and number 3. Number 1 is, if you talk to students, many of them will claim an affinity for algebra or geometry. Reflecting on your own predilections, do you like algebra over geometry or geometry over algebra? Provide some examples or a discussion that illustrates how your preference influences you as a math student. So the one thing I would say is I definitely prefer algebra over geometry. And it's not even a question. Do I hate geometry? Do I dislike geometry? No. It's just my geometric intuitions they are not even close to my algebraic intuitions. Variable sense making, equations in algebra, slope form, quadratics, roots of a function. I just love algebra. I can write a book about it. I'm serious. I love algebra, I love stats, I love calculus, but geometry, it's not my cup of tea. I'm not going to sit there and, hate on it. It's just, I'm biased because my brain's it's not spatial. My spatial sense making and just in general, my depth of perception, I would probably say it's pretty porous. Can I do geometry? Can I get an A or B? Yes, I could. I understand geometric principles. I understand that, okay, we have two angles. It's not gonna, well, actually, to be honest, okay, never mind. We have two angles. We can prove that similar. Okay, the similar postulate, AA postulate. Okay, we have a proof. Angle 1 is equal to angle 5. Why? Well, they're corresponding angles. We got two parallel lines, a transversal. I can do geometry, but I'm not even saying it's that bad. It's just, if I had to pick a mathematical skill that is my worst, it is my depth of perception. It's 3D figures. It's seeing things, my brain it doesn't work that way. I'm not creative. I'm not a person who, I like the creative aspect of geometry. I love how in proofs we can go about it in so many different ways, in proving why triangles could be congruent, in maybe finding the perimeter area or finding the angle. There's different routes. I love it. But I feel like sometimes, especially for when we're teachers, there is a huge distinction between geometry and algebra. In algebra, it's more straightforward. I'm not saying you're just solving for X, but for ninth graders, that is a huge theme. We have equations. Sometimes it's multi-step. Sometimes it's straightforward. It's quadratics with squares. It's going into factoring. It's very equation heavy and more it's more quantitative reasoning skills, 2D, and things of that nature. When we go to geometry, it's not just solving for X, it's not just solving equations, no. You're doing that on top of some spatial reasoning skills and that depth of perception. Let me give you an example. I have two angles. They add up, I have a diagram. Okay, I have a diagram, right? And you're supposed to solve for X. And I have two parallel lines and a transversal. These two angles right here, one of them is x squared minus x squared minus 16, and the other one is like another expression, like x plus 52. You know, I'm just naming numbers, right? Not only do these students have to recognize that these are corresponding angles and thus they will be equal, but they also have to get the step of algebraic reasoning skills to then set up the equation to solve for x. Does that make sense? So what makes geometry so tough is you're using geometric principles. You're using geometric spatial senses to set up an algebraic equation that you can then manipulate to solve for the variable. But if you don't understand and see, okay, in that diagram, I see this or I see that, or the surface area is going to be this, 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 so I'm going to set it equal to that, and then that. If you can't even set up the algebra, let's say your algebra game's good, but your geometry's not, I'm sorry. I know you can solve for x if you get to that step, but you got to get to that step first. And, reverse that. What if your geometry game's good, and you know the angles, but then when it comes time of the quadratic, x squared, and you solve for the roots, oh shoot, your algebra game's not good. So it's really, 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 really interesting that some of us as math students, we are able to have, and some people have this, they're really proficient in their spatial sense, in their 3D sense, and also their 2D sense. But I feel like for me, I've always been a 2D guy. It's not that I can't do 3D stuff, it's just my brain had to work harder for it. It didn't come natural to me. And I just feel like in terms of how this influenced me as a math student, I have always had to work harder being a geometry student, putting more time into the homeworks, sitting down, understanding these proofs than I did for algebraic proofs. And that's just because my number sense, number theory, quantitative reasoning skills. It's why stats and algebra are my two favorite subjects in math. That's why I prefer algebra. But hopefully that whole thing made sense, what I was talking about with the whole connection. It's really cool how that works. And how, as future math instructors, we have to realize that if we do teach geometry, just know that there's actually algebra interwoven in that geometry curriculum. It's a matter of, how do your students do? Are they getting the geometry parts correct? And then when it comes time for solving for x, they do it incorrectly? Or is their x game good in solving equations, but they can't set up the equation because they don't know how to find the area, or they don't know what alternate interior angles are, or they don't know geometric means, etc. Similarity, right? Number 3, what was new or most interesting to you, and how did it change the way you think about or perceive things? So, I did the reading, and in Cook's reading, it was part 5 or 6 of the book, and I'm on page 345 here in Cook's book. The slide rule. The slide rule was an instrument that they used that let them multiply and divide. Like, it wasn't a calculator, it was literally like this thing, and they slid this tool, and you were able to multiply and divide large numbers, do even some log functions, some exponential functions, and it was pretty much what they used in schools before calculators. Electronic calculators. And it's just, that really interested me the most. Because how does this change the way you think about or perceive things? Well, let me just say this right now. We are blessed in 2022 to be having these TI-84s. Do you know how advanced those calculators are? I mean, geez. I mean, I even had the quadratic formula. I can give the A, B, and C value, and even if it's irrational, it'll give me the roots. And it's just like, what a bailout. We are very fortunate as math individuals to be given calculators today. And I mean, it comes with pros and cons because being a teacher, we have to understand our students can't get too comfortable with these, calculators. But the slide rule, you weren't able to do, like, yeah, it still did, like, some large computational things for the students, all that stuff back then. But with calculators now, I mean, I could even use Math 9 and input an integral, and it'll find the antiderivative for me. Not only that, but I can do the bounds of integration, and it'll solve the bounds for me for what the area under the curve is. And it's S&P 5. It's using tools strategically and really thinking about the slide rule. And also what interested me was in chapter 31 of Cook's book, perspective geometry. That also, or projective, not perspective, projective geometry. And how you can go about geometry from perspective. But like, math is its own thing. I mean, I'm already at 12 minutes here. I got to end it soon here, but I mean, geez. I mean, you really think about it, though, how different tools were back then and how that would have changed the way that we teach, the way that we go about mathematics. I think we're very fortunate that we're not doing as much on paper and hand, and we can input in our calculators. So I think it saves a lot of time to go about mathematics efficiently, but with technology also comes cons, and we can become too used to it that when the calculator is taken away, do we understand the fundamental roots of what we're actually doing? So, like, for example, the quadratic formula. Do I understand that it's negative b plus or minus this, the b squared minus 4ac all over 2a, all that stuff, like, or it's minus 4ac, whatever. But, like, do I understand that? If I do, then fine. Let's use our calculator just to save time. But you see what I'm saying? So I don't want to go on a tangent, but we're going to go from there. Take care. Those are my 2 prompts. Hope I didn't talk too much. Have a great day. Bye-bye.